Alright, in this video I'm going to go over this example which is in the notes, and we are supposed to find the Thevenin equivalent of this circuit, which is this part of the circuit here, and then find the power that will be delivered to two loads. These are two separate questions. Number one, if the load is a 10K resistor. Number two, if the load is a 5-volt voltage source. So let me read the circuit without this additional things that might be confusing. So I have a voltage source 15 volts here in series with 3K, then a 6 ohm resistance, 6 kilo, and a 2 milliamp current source, a 3K resistor here, and a 4K over here, and the load, whatever it is, it will be attached across these two terminals. So you would like to find the Thevenin equivalent of this circuit. Now I noticed that if I transform this to a current source in parallel with a resistor, then this 3K and 6K will be in parallel and can be combined. So I do this, I transform this to a current source in parallel with a resistance which is 3K. What's the current? 15 volts divided by 3K, which will be 5 milliamps, and then I have the 6K in parallel with this, then the 2 milliamps in parallel with this thing, and 3K and 4K over here. Alright, now I noticed that these four components are all in parallel, so I can combine the current sources and I can combine these two, 3K and 6K. So these current sources, they are in parallel. The combination will be 5 milliamps going up, 2 milliamps going down, so the equivalent will be 5 minus 2 because this is going in the opposite direction. So 3 milliamps going up. So let me draw it here, 3 milliamps going up, and the combination of 3 and 6 will be 2 kilo ohms. And then I have a 3K and 4K over here. So the next step, I noticed that if I transform this combination to a voltage source in series with a 2K, then I will have all my components in series and I can combine all the resistors. So I go back to turn this back to a voltage source in series with a resistor, and I already had these two resistors over here. So how much is this voltage? It is 3 milli times 2K. K and M cancel, and 2 times 3 is 6 volts. Alright, and now I notice that these components are all in series, so it doesn't matter if I switch them around. If I switch these two, these three resistors will be in series and I can combine them. 4 and 2 and 3 will be 9 kilo ohm, and 6 volt battery. So this is my Thevenin equivalent of this circuit over here. Alright, now the question is find the power delivered to a load of A 10K resistor, B 5 volt voltage source. So these are two separate questions. So what I do is I first attach a read circuit here, the Thevenin equivalent, 9K, 9 kilo ohm. So I'm supposed to attach a 10K resistor as a load. So what is find the power delivered to this load. So how can I find the power delivered to this? I can find the voltage across this and then use V squared over R, or I can find this current and then use Ri squared. So perhaps it's easier to find the current. This is a single loop, so the current in this loop will be the total voltage divided by the total resistance. So this current will be 0.32 milliamp, and the power, which is Ri squared or 10K times this current squared, the power will be 10K 10,000 times 0.315. So the power will be almost 1 milliwatts. So the power delivered to a 10K resistance will be 1 milliwatt. Alright, the second part of the question is, now my load is not a 10K resistor. The part B is, my load is now a 5 volt voltage source. So I have my Thevenin equivalent again, like this. So in this case the load is a 5 volt voltage source. So I assume this would be the polarity of the voltage source. So what is the power delivered to this source now? So for a voltage source we cannot use V squared over R or Ri squared. The only way is to find this current and then use P equals Vi. So the current in this case will be the total voltage in this loop, which is 6 minus 5. Because of these polarities, I cannot add them up. It's not 6 plus 5. They counteract each other. So I had the total voltage is 6 minus 5, 1 volt. And the total resistance is 9K. So the current is 1/9 milliamp. And what is the power delivered to this load? I can use VI, which is 5 volts times 1/9 milliamp, and the power will be 0.56 milliwatts. This is the power delivered to the 5 volts voltage source. Alright, this completes this example. I just wanted to complete this other example that we did in class. So the question was to find the Thevenin equivalence seen by this load. We said that we have to do 2 separate circuits, one for the open circuit voltage, the other one for the short circuit current. So the short circuit current we found in class was minus 1.5 amps. The open circuit voltage, we have to solve this system of equations. And I know that VA here is 40 volts. So I can now solve this system of equations. You can use whatever method you want. I like to use the Wolfram alpha here. So 40 minus VB over 60. 40 minus VB over 60. Minus 2 minus VB over 180. Minus 2 minus VB over 180 equals 0. And the second equation was VB minus VC over 15 equals 2. VB minus VC over 15 equals 2. So the solution here is so let me double check the equations again. VA minus VB over 60. VA is 40 minus VB over 60, minus 2 minus VB over 180, minus 2 minus VB over 180 equals 0, and VB minus VC over 15 is 2, VB minus VC over 15 is 2. Alright, so I guess the problem here is if I have 2 variables here, V and B, and it's confusing the software. So let me remove all the V's and do this again. Alright, now my VB is minus 60 volts and VC is minus 90 volts. So I go back here, and now I know that VC is minus 90 volts. So the open circuit voltage is minus 90 volts. Because this is minus 90 and my short circuit current is minus 1.5. My Thevenin resistance is the open circuit voltage divided by the short circuit current, so it will be 6 ohms. Alright, so the Norton equivalent is this. So for the Thevenin, this resistance should be in series, not in parallel. So but the important is, because my short circuit current is negative now, my Norton equivalent will have direction for current, and because my open circuit voltage is minus 90, my Thevenin equivalent will have this polarity, which is the opposite to what we normally do, but that's totally right. So this will be 90 volts with this polarity, and 1.5 amps with this direction.